was the difference between velocity and speed for those people who were out? Somebody tell me the difference between speed and velocity for those people who were absent. Go ahead, Jacob.
Velocity is the amount of speed to go in direction.
Velocity has direction and speed.
Okay, that's what Jacob was saying. You were just pushing him there.
Speed is how fast you're going at that amount of time.
Okay. So speed does not have direction and velocity does. That's the only difference. So when we calculate this answer, we have to put a direction on it. So Anna Lucia said velocity equals distance over time. So my distance here is what? Since we're finding velocity, what's my distance? 500 miles. Over what's my time?
6 hours.
Over 6 hours. So we would do just like we did with speed, was 500 divided by 6. 80 point what? 83 point. All right, miles per hour. Now, this is the piece that was different yesterday when we do velocity. When we do velocity, we have to write a direction because velocity specifies direction. Excuse me. So we write 83 miles per hour east. Like that. Questions? Oh, it said west? Excuse me. I didn't actually read the question. My bad. Been one of those days. All right. I wasn't actually here this morning. I had to sub for the first half of the day. All right. Number 2. How far did a car travel in 6 hours at a velocity of 75 miles per hour west? So what are we solving for if it says how far? Distance. Okay. So you can either use velocity or speed. They're the exact same formulas. We're going to use velocity since that's what we did yesterday. So what are we solving for? You said distance. So we got to have V and T. Now, when we were doing this in class the other day, I said the easiest thing to find was always the what? The V or the time? The time. So what's the time? So that means the 75 has to be the what? The velocity. So if you know that, what do you do to solve for the distance? Cross multiply. So distance is going to equal what?
450.
450. Look at your units. This and this. What's going to happen? The hours are going to cancel, and I heard miles was the unit, which is correct. All right, last one. Now, if a car travels 55 miles per hour east and a wind blows 15 miles per hour east, what is the velocity? Now, I'm asking for velocity, right? Now, the problem we have here is people look at this and go, it's almost velocity. Distance over time. Did I give you a distance or a time?
No.
So how are we going to find velocity if I don't give you a distance and a time? Okay. This is one of those combining velocities. I gave y'all 2 velocities. The question is, are the 2 velocities going in the same direction or different directions? Because they both say east, you know what? They're going the same direction. So you're going to do what with them?
Add them together.
So 15 plus 55 is 70 miles per hour east. Questions? Now, at this point, hopefully you have 10 openings. If you don't, let me say this to you. Ask yourself as a student, am I the type who will come at lunch or after school and get the opening that I'm missing and turn in my 10 openings? If you are, then finish it at lunch today. If you know yourself and you know, nope, that's not me. I'm never going to finish these openings. I have 8 of them. I have 8 out of 10. Then you need to turn in the 8 out of 10 and get your 80. Okay? Because if you don't turn in the 8 out of 10 today, tomorrow, the next day, what grade do you get? A 0. Because once I hand back the openings you hand in about 3 days, I don't take them anymore. Because what do people do with the openings I hand back? They just copy them, and I won't take them anymore. Okay? So, if you know that you are never going to finish your openings, turn them in today. But if you know, let's say Caleb was absent yesterday and he's missing yesterday's opening. If he's the kind of student who will come in during lunch and finish yesterday's opening, he's like, no, I want my 100 this fall. Coming at lunch today, get yesterday's opening. He needs to hold on to his opening and finish it during lunch. Okay? So you evaluate that. But if he's like, nah, dude, I'm good with the 90. I got 9. I don't need yesterday's opening. 9 is good enough. Go ahead, get a stapler, and turn them in. Now, 2 things. Number 1 is your name on the first page. I do not know y'all's handwriting well enough yet to figure out whose is whose. And every year I do this, every time I take up openings, without fail, somebody forgets to put their name on the page. Number 2, I'll just clear them mark, because I'm only going to count them twice. And if I count 9 twice, you're getting a 9. And make sure they clear the mark so I can count 10. If you have all 10. Okay? And then put them on the stool. If you need a stapler, I'm putting a stapler right here so you can staple them together. If you're Jacob and you only got a page, just make sure your name's on the front page. Okay? That's a lot of people say. What do you do? Scan sheet?
I know, I figured you.
It's okay. Every year I get somebody to go scan sheet. It's okay.
Just
I'm
10
sure
sheets.
you do it. Not very environmentally aware, but I can tell you.
I put big numbers.
Work well. It's okay. I can find it back. I'm smart. I turn the paper over. Stay where he is. It's okay. Yep, I got it. Nice and big. I won't lose it. And walking around checking homework. All right, those of you who are absent and need to turn in homework, I should not see you writing or working. All right, Alizé's already mostly done with hers, so she just needs to not work on hers, so I don't think she's copied down the answers. All right, so in walking around, the vast majority of you had number 1 and 2 without difficulty because they're just like what we were doing in the opening. All right, so when you look at number 1, you had speed equals distance over time. Distance is 1,000, and time was 250. So most people had no trouble coming up with 4 meters over seconds, right? That one was pretty easy. What are we solving for? Number 2. Distance, right? So speed equal distance over time. Speed was 21,000. Distance we didn't know. Time was 5. What would we do to solve there? We will cross multiply. What is that, 105,000? Somebody tell me if I did that right in my head. Yes? All right, kilometers. Now, those were the 2 when I walked around, everybody seemed to have without difficulty. It's when we get down here to number 3, we start to run off the rails. People start leaving blank spots, and then we just were like, this is all I know. All right, so what happens when we get to number 3? Because you're going to see this on the test. The test is Friday. All right, I made it Friday for Logan because he said he had 2 tests on Thursday. Then I go to 4th period and I have 2 kids in 7th. Well, I already have 2 tests on Friday. But I'd already promised Logan we'd make the test Friday, so the people in 4th period just got screwed. All right, so they have 3 tests on Friday.
But they test on Thursday.
It's already on Friday. I'm not going to test one group on Thursday and one group on Friday, so it's just Friday. All right, so when you look at this on Friday, how are you going to work the problem? Okay, every time there are 2 times. What do you do with 2 times? You subtract them. All right, so the only way you guys can get good at this is to do what with the problem? Practice it. Okay, instead of telling me, I forgot I had homework. All right, I don't give a lot of homework. How many nights have y'all had homework in 10 days? 2, maybe 3 tops. Okay, I'm not a big homework person in physical science. You will have some homework. This was 8 little cheesy questions. It was not a lot. So you take the 2 times, 10 minus 5. The problem is you have no distances. Where do you find the distances at when you don't have them? You got to find them in the chart. So go here. Here's the 5. What goes with the 5? 30. What goes with the 10? So you say 70 with a 10, 30 with a 5, and what do you do with those 2 numbers? So 70 minus 30 is 40, 10 minus 5 is 5. What's 40 divided by 5? 8 meters over seconds. Now, for number 4, how do you find average speed? When we did the lab on, I need to hand back this grade. This here is total distance. This is total time. So what's the total distance he went? 120. The total time it took him.
20.
So that was 6 meters per second. Now, in number 5, when I ask if it's constant or average speed, what can you tell me about those 2 numbers? Are they the same or are they different? Are they the same or are they different? They're different. One's 8, one's 6. If it's constant speed, what do all the numbers have to be? The same. So is it average speed or constant speed? It's average speed. You don't even have to graph it. Now, number 6, 7, and 8. Let me blow up this graph and make it bigger so we can read it a little better. Okay? Let's see if I can get this graph on here. I might have to put the questions under the thingy. There we go. All right. So, number 6 says, where is the object not moving? Where do you look on the graph to see not moving?
That's straight.
Where it's what?
Horizontal.
Horizontal. Okay? This right here means we're not moving. That flat spot means we're not moving. So, you could have either told me in number 6 it's horizontal, or you could use the times. So, what time is it not moving?
50, 20 through 50, 40.
All right.
50, 30.
All right. Those would be distances. So give me the times.
Like 50.
If you read down, this would be what? 15
30.
to 30. So 15 seconds to 30 seconds. Now, 7 and 8. What do you do anytime you have 2 times? Okay. So speed equals 60 minus 10. What don't we have? We got to find distances. Where are we going to find them? All right, so I got a 10. 10 up to the graph is here. Where do I go from there? Whoops. And draw a very straight line. All right, it's 30. All right, so 60. Gives me right there.
110.
That's 80, 90, 100, 110. So 110. All right, so 110 minus 30 is? And 60 minus 10 is?
50.
Okay. So 80 divided by 30 is,
80.
oh, that's 50. I can't read my own handwriting. That's 50. All right. So that'd be 1 point. Somebody divide that for me. What's 80 divided by 50?
1.6.
1.6 meters over seconds. Okay. Now the last one. All right. Speed equals distance over time. All right. I get it. Yeah. So how do we do average speed? Where do we go on the graph to get average speed? Where do you think?
130 and
Why are you going there, Jacob?
because
You have to go to the very end. Right here is where you go for average speed. So what's the end of it at?
130 and 80.
So 130 over 80. So what's 130 over 80?
1.6.
So when we did the time there, I came pretty close to the average speed of the graph. Questions about your homework? All right, we're going to do some more math calculations in a minute. We're going to finish acceleration, and we're going to practice some math because we cannot do the chewing gum lab if we can't calculate. And right now, we can't calculate. And the chewing gum lab, number one, is you can have a partner to help you, but everybody does their own calculations, okay? Because you're chewing what? Your own gum, okay? William's chewing his own gum. Anna Lucy is chewing her own gum. Chase is chewing his own gum. Is everybody going to have the same number of chews on their gum? So everybody's going to have their own calculations. So you have to be able to calculate in order to do this lab. Whereas in the other labs, everybody had their own data. So if you got stuck, whose data could you use for calculations? Your partner's. You got to be able to calculate your own. Quit throwing that thing in the air. All right. So let's talk acceleration. Does everybody have a calculator today? If you don't, get one. Carla, do you have one? You do or don't? Okay, would you be ever so kind to give Carla a calculator? And for those of you who've not met Carla, you'll meet her over the next few days. We have a new student. Carla is joining us for the rest of the semester. And I believe she's new to the school also. So y'all be very kind to her. All right, so we did this yesterday, for those of you who were absent. We talked about what acceleration is. Somebody tell me what acceleration is. All right, the rate of change in velocity. How much velocity changes? All right, so we were talking about this yesterday. How much velocity changes. So when class ended, I was trying to convince y'all that there are 3 ways for an object to accelerate. And some of y'all were looking at me like I was nuts. So we can do what 3 things to accelerate an object?
Speed up, stop, and turn.
Okay, we need to fix that second one. We can speed up, which is known as accelerate. We can, instead of saying stop,
Decelerate.
we can slow down, which is often known as decelerate. Okay? Now, physics snobs don't like to use the word decelerate. I think the vocabulary is wrong there.
Increase.
A lot of people like to use positive acceleration and negative acceleration instead of accelerate and decelerate. I'm not a physics snob, so I still like accelerate and decelerate. All right, but we're going to use positive and negative acceleration also simply because when we calculate, we're going to get positive and negative numbers here. It's one of the few places we will get positive and negative numbers. So if you get a positive number, it accelerated. You get a negative number, it decelerated. And then the one we were talking about when the bell rang is if you change directions. So, was it a scalar or vector quantity? It was a vector. Now, it's not what I wanted. Apparently I don't have what I wanted. We already did this. All right. Can an object at constant speed accelerate? All right. Can an object at constant speed accelerate?
Yes.
No.
I got some no's, I got some yeses.
It's yes, change direction.
No, it's not.
The speed's not changing. No, it can't. Constant never changes though. No, because the constant speed never changes.
That means the speed's going
So if
to
you go
change.
with 90
It's
miles an hour,
constant.
Average speed.
What?
Yes or no?
No.
So I got 3 no's and I got 1 yes.
I'm just saying.
All right. So let's say I use the same example I did yesterday. Not a very attractive picture, I realize. Will it go at constant speed?
Yes.
No.
Ferris wheel goes at a constant speed and it changes the
Yeah.
It will eventually reach constant speed. Once it gets going, it will reach and achieve constant speed.
But it's still,
Will it accelerate?
Yes.
yes, because of time.
Thank you. Jacob.
Okay.
Thank you very much.
The answer is yes. All right. The answer is yes. Now, why?
That just changes direction.
Because it's
It changes directions.
Exactly.
Okay? You guys get so fixated on the word speed and constant. Okay? Don't fixate on the word constant speed. That is not the important piece. Okay? When we talk about acceleration is not just about speed. Acceleration is also about direction. So, if you change directions, you are accelerating. It's that simple. You do not have to change your speed at all. Whether you are speeding up or slowing down is irrelevant. If I walk this way and I turn, I accelerate. If I turn this way, I accelerate. I accelerate. I accelerate. I accelerate. Okay? Did I really go any faster?
No.
No. But I accelerated because I did what?
Change direction.
I changed my direction. So when you're on a Ferris wheel, you're changing directions constantly. You're accelerating. Now, if you're riding a traditional roller coaster, yes, you accelerate and decelerate constantly because of the up and down hills on a traditional roller coaster. But on a Ferris wheel, it's much less obvious because you're just subtly changing the direction. Now, let's talk graphs. Okay? How would an increasing acceleration graph look like? Okay? Now, we can draw a diagonal. No problem with a diagonal. Now again, diagonal means nothing unless we label the axes. So what does the X and Y axis have to look like? Distance and time, all right? If I label distance and time, what if we learned distance and time this graph was? Constant what? Constant velocity or constant speed. So that can't be increasing acceleration because that's constant speed or constant velocity. So what do I need to make that?
A V.
Make it a V. Now it's increasing acceleration. Now, if we want to do distance and time, I told you I'd tell you that one today. Distance and time has to change at a changing rate, so it has to have a curve. Okay? If you put a curve in it, then you can use distance and time. But it's not going to be a uniform change. It has to have a curve to be acceleration. So, how would we draw it to show decreasing acceleration? Okay?
Going out. The DT would go.
Like a heel.
It just has to do basically what?
Flip it.
It has to be flipped. It has to go backwards. Now, when I said not accelerating, what do you suppose I mean by that? So, what kind of graphs could we draw? Okay, so if I draw a horizontal line, what do I mean? Got to label the axes.
V and T.
Okay, V and T would be what?
Velocity.
Yeah, I know that. But if I put V and T on it, what's your horizontal line mean? Because you got to know what these mean. You're going to see them on the test. All right, so the V is doing what? What's the velocity doing? Velocity staying the same. So what is it? If velocity stays the same, constant, there you go. These are the things that need to run through your head. Okay? You guys have math skills. You've learned these things. You learned these things way back in school. A flat line means it remains the same. What's on this axis? Velocity. Velocity remains the same. Constant velocity, constant speed. Okay? What if you put distance here? All right, what would that graph be? Okay, Jacob and William cannot answer. All right, what would that graph be? What would that one be? What were you going to say? I don't shoot people for being wrong. I get mad when people won't answer. Mm-mm. Mm-mm. Constant acceleration would be more like this because velocity and time are changing at the same rate. Okay? What's not happening in this graph? That's right, because distance is not doing what? That's right. Okay? So this would be not moving because distance is not changing. This is y'all right now. Your distance is not changing, so y'all are not moving. So what? But time is. Time is passing, even though slowly, but your distance is not changing. John is praying for the end of class. All right. It's coming. All right. All right, questions. All right. So, what type of graph would that be? All right, you could just say acceleration. That would be fine. Increasing acceleration is fine. Let's say we wanted to find how much it accelerates. How would we do it? If that was on the test, you don't have to write it down because it's a big graph. How would we do it? What's the formula for acceleration? All right, let's go back for a minute for those people who were not here yesterday. Somebody tell me the formula so we can write it down for those people who are not here. Okay, so acceleration equals, and this one's written funny on your orange sheet.
Change in velocity, triangle.
No, it's velocity S, velocity I over.
Now, that's the way it's written on your sheet. Okay? Now put the triangle there. Okay, this is what it looks like on your orange card. All right, and I told you I don't like the way it's written on your orange card because you're not always going to need to subtract VF minus VI. Sometimes they may just give you the velocity. So it's the same thing as writing triangle V over triangle T. If you have two velocities, you subtract them. If you have two times, you subtract them. But are you always going to have two velocities? No, but this is the way the state has written the formula on your card. Okay? And the triangle just means you subtract if you have two. But this is the way they gave you the formula on the card. But you're not always going to have two velocities. You will a lot of times, just not always. So when you look at this, how many times did I give you in the question? So what do you do with them? Okay, so A equals 50 minus 10. Now, did I give you the velocities in the question?
No.
So where do you find the velocities? Find the graph. So find the 10. Let me get a different color. Go back. All right. So find the 10. Go to the graph and go over.
35.
Okay. All right. Find the 50.
35.
Go over. And what do we have?
35 minus 5. So it would be
35 minus 5 is
30 minus 40. I mean 30 divided by 40.
0.75. And I don't have any units on this one. Let's just say it's meters over seconds over seconds. Because I'm going to teach you the units here in a second. Yeah, I'm going to show you the units in the next one. All right. So, write this one down. And we'll talk about how to write the units. Because the units of this one are a little different. Because with acceleration, we keep all the units. What's today? Tuesday?
Yeah.
Okay.
Yeah.
Yes. Now remember, because we put the test on Friday. If we're not here Friday, but it's the test.
No,
Making that clear. It's the day we come back. Making sure we're clear on that. And who knows? We may not be here Friday. I have no way of projecting that, but I would not be shocked. Given the forecast, I would not be shocked. A lot of
It might
rain,
kill
some
y'all,
wind.
don't say us.
It could kill all of us.
It's not going to kill all of us. We're going to get wind and rain.
Not DH at the camera.
All right, so we want to find acceleration, okay? The question says, what is the acceleration, right? So, A equals, and I'll just write VF minus VI over T, just because that's the formula. But again, if the question does not give two V's, do you have to subtract?
No.
No, you just write the one velocity it gives you on top, okay? Not all questions will give you two velocities. So, for those of you who were not here yesterday, this also means I means the first velocity, final is the F, that means the second velocity. So when you read the question, all right, what is the first velocity given to you in the question? How fast is the car going at first? So that's the VI. Minus what's the second speed or velocity of the car? Okay? Over how fast? Okay? Now, when we calculate this, 35 over 6. So we get what? What? 5.8. Now, our units in this one are a little weird because this is miles per hour, and that's seconds. In acceleration, when we divide, nothing cancels out. So everything stays in acceleration. So you write miles per hour per second. You keep it all. Okay? Everybody got it? Now, hey, while you're here, open that Carolina box for me. I know what's in it. All right, so this would be one where you wouldn't necessarily need to subtract. All right? Oh, box. All right, what's the velocity of a falling object with an acceleration of 9.8 meters per second in 5 seconds?
What?
I just read the question. Just write it down.
That's confusing. She said.
Probably a little rinky dinky thing. What is it? I don't know. You. Take the paperwork. I ain't doing that recycling. Back there, if you want box, you can have it. I just don't put recycling box for Friday, but you're welcome to it. Now, often people look at this and they think, oh, this one lasts for velocity. So what's the first formula that you think they go, oh, what do I need? When it says velocity. Mass. There's no mass of velocity. What's the formula we learned yesterday for that? Okay. So that's what most people think. When they read what is velocity, that's usually the first thing they think of. Okay? And then they look at it and they're like, I got time. So I got 5. And then they go, I ain't got distance. So is that the right formula if you've got time but you don't have any distance? No. Okay? So I want you to start getting used to the idea that I have this formula that has velocity in it. Well, what other formula do we have that has velocity in it? The one that we just learned yesterday. We have this one too. Okay? So we have more than one formula that has velocity in it. So when you look at this and you see the word acceleration, okay? That's going to tell you, okay, I don't need this one. I need that one. Does that make sense? So if they give me acceleration, I need this formula. And where am I going to put that 9.8? In the A, the V, or the T?
A.
In the A. So 9.8 is going to go there. All right. What is 5 seconds? What is 5 seconds? Is it a velocity or a time? It's a time. Now, they asked me to find a what? A velocity. Now, this is why I don't like the formula the state gives you. Am I solving for one velocity or for 2 velocities? One. So we're just going to write V there. We're not going to write 2 velocities because you're not looking for 2 velocities. So how do I solve for that? Cross multiply. See if that's 49.
It is.
Okay. Now, when I cross multiply, what happens to this second and those? How many cancel out? Only one. You get meters per second. Does that make sense? Okay, we're going to do one more just to show you what happens when you decelerate. All right. Now, if you were listening to me a few minutes ago, what you looking for, Thornhill?
Dropping bottles, the bar's dropping bottles. How many more bottles?
That are new?
Or just something I can put the sodium hydroxide in. It's okay if I just put the whole beaker. Okay. I don't wanna, only because it's the right molar, and I was just gonna put it in one of those. Things that make science people happy.
Thought it would be easier than 200 for an hour. All right, so when we decelerate, if you were listening a while ago, what kind of number did I tell you we were going to get?
Negative.
A negative number, okay? So, what did I tell you about this formula?
It works now.
It does work. But, what I say about VF, it's the what velocity, the first or the second? It's the second, and VI is the what? Okay. If you put them in the right order, your number will turn out to be negative. If you forget and do it backwards, your number will come out positive. But as long as you remember deceleration is always negative, you can fix it. Okay? So, if you do it correctly, who is the first velocity? So 75. Who's the second velocity?
25.
Over, what's my time?
2.
10.
I'm thinking 10. All right, so 25 minus 75 is negative 50. Oh, okay. So negative 50 divided by 10 is negative 5. And we have miles per hour per second. Now, that's the way the problem should work. Now, let's just say for a second that Damien forgot on the test. And he said 75 minus 25 over 10. And he got 5. Now, all he's got to do is remember what? It should be negative, and then you do what, Damien? That's right. You remember, oh yeah, Miss Wall told me it's negative. And then you do that, and you're good to go. Okay? You just have to remember that deceleration is what? Negative. So if you do it backwards, you do what to it? You put the negative sign on it, and you're still good to go. Okay? That's all you got to do. Everybody hear me say that? Okay. If you do it correctly, it comes out negative. But if you forget, you can just add the negative sign at the end. Yes? No? Okay. We're going to practice a little math before we try to do this by ourselves. Math. All right. Somebody come get this. Now, this has speed, velocity, and acceleration all mixed up. If we do it well, we're going to try the bubblegum lab. Carla, can you chew gum? No. Okay. Yes, ma'am. Yes? Come get the hall pass. At least you're going, Ashanti. Huh? Come back on this door. We just close it so we don't have to listen to this record. What? Oh. You need me to buy some sugar-free kind of stuff? Sure? I might even have some back there. I just bought fresh today, and it's the other kind now. I didn't even think about braces. I don't usually get a bunch of folks in high school who have braces, but I don't have them. She's a junior. She's on 4 years. She's pretty pissed about it.
I'm on 3.
All right. Now, I'm going to roam amongst you and help you solve what you need help with. Remember, the three formulas you guys are using are speed equals distance over time, velocity equals distance over time, and acceleration equals over time. Those are the three we're practicing. The lab that we want to do uses acceleration. Okay? That's what we're trying to master. Okay. I will change that. I'll put them in. Yes, sir. All right, everybody's had a chance to start. So who's got a question? They're stuck, they need my help. How about you? Start up here at the front. Stuck. Number one answer. Which one up there? So right down. Now, if you're like Alexis and you just told me this is a little itty bitty space, do you have to do it on this sheet of paper? No, you can do it on a separate sheet of paper if you write large like she does and there's a little itty bitty space. Okay, so don't feel like I'm making you do it on this sheet of paper. Does that help? Okay. Yes, wait. Just bring it here. All right, so just all into the sheet. So the distance and the time. So what's the distance? Yeah, I didn't just say units now. Maybe you'll make them up if you want. Huh? See what? Oh, yeah. Also stuff. Okay, can I calculate? Here, you stuck? Put you on the board number 2. Okay, which one up there is distance? Yep. So, right there. Okay. So write D over and equals, you know what you're solving for. Off to the side somewhere where you go space to work. All right, so you know the time. What is it? It's what? Which number are we doing? 2?
Yeah.
How long did it take? Is that distance or time? It says how long did it take? You want to have T on the bottom, so we need to figure out the distance on top and the speed. Same for you in number 2. Okay? So, okay, so which one do you want? 2? Huh? Okay, I'll be there with. Divide by it, you can do it. So we can T on the bottom. Equals. Alright, so you gotta figure out what's the distance, put on top. So what do you think the distance is we're putting on top? 3. That's what? What says here? What is question 3, so what will be? Yes. Okay, so that will be the speed is what? Yep. So. Now you think you can solve it? Okay. Can you solve it? Right? Okay. Right? What? Yeah, she said that 2 XRs. We got 2, sorry, we heard 2 losses 2 times. Yep. All right, we're here, Tristan. No. combine any velocities. You don't need it because you've got two velocities going the same or opposite direction. All right, we'll solve for number 1. We gotta have a distance at a time. What's the time? Yeah, solve. How do you do that? What's that doing right there? 650 divided 12. Yep. Yes. Yes.
I'll put 296.
The distance will be
That's
2,965.
Yes. So, yes.
The crosswalk.
Yes. So you get 325 D equals. You cross multiply first. You gotta do 2 steps. You're gonna cross multiply first. Okay? For those of you on number 2 who are stuck. Okay? Y'all are setting it up right and doing your math wrong. Get on board. Wake up. That's not what I want. All right. Y'all have 325 equals, was it 2965?
Yeah.
Over T. And y'all said cross multiply. That's right. You get 325 T equals 2965. Now that you've cross multiplied, what do you have to do? Now you got to divide by 325. That sounds about right. Looking at those numbers. Okay, but you got to cross multiply first, and then you divide. Okay, those are 2-step problems when the variable's in the denominator. Okay. What do you do if you have 2 times? You got to subtract the times. And then you got to find the 2 distances that go with them up here on the chart. Okay? Go check on my new student. Number 2. All right, Carl, what are you doing? What do you have to kind of do this? Can you do any of this? Okay. At the end of the class, let's see if I can get you some numbers. Okay? But the formulas are back and forth now. Let me get you a formula sheet. Because I know you don't have one of those. First 2 velocity, acceleration, speed is the same as velocity, which is why it's not on there. Okay. Stuff. And we subtract the 2 times, match the 2 times the distances together. You're going to have speed equals 2 times are 60 minus 20. You got to match them up. So times 60 goes there, 20 goes there. So 80 minus 50. Okay. Got it? Where? Because it says headwind, yes, you would subtract because the wind's going in front of the plane. If it said tailwind, it would be pushing it. All right, yeah. Almost. The only thing that you did wrong is see how your negatives are going to cancel out. Typically, we do big number minus little number, like 60 minus 20 and 80 minus 50. But yes, the process is correct. And we also need to flip it. So you have time on top because the formula is speed plus distance over time. Your times need to be on the bottom and your distance needs to be on the top. That's the only thing that's wrong with this one. Huh? Except that it needs to be flipped. So 30 on top, 40 on the bottom. Here. There are the answers. William, you can check. No, I said William can check because he's done. You can check. You're finished. Do not let him check. Yes. Yes. Now those two, you got to do your formula. Speed equals distance over time. You got to take your two time numbers. What are your two time numbers? So 60 minus 20. And what are your two distance numbers? So 80 minus 50. Okay?
Okay.
Who else has a question? Okay, question? Yeah. It's canceled.
I just need to redo number 2.
Equals.
I read number 3. I did that. I just flipped them.
Yeah.
What? I don't know how long to look. Yeah.
Yes. Yes, ma'am. Well, all right. Whenever you have two times, what do you do 2 times? You know what? Yeah. Speed equals distance.
I did number 11 wrong.
So on the bottom, you're going to do what with these two?
Oh, did you know number 11 wrong too?
Minus
Where'd you get that right?
20. Now, you gotta use your distance to go with it. So 60
She got 23. I don't even know how she got that.
here, so your 20 is here. So,
How do we do?
oops. Okay, from the 60. Okay, that's right now. So for your 80 here, 60.
I don't got some of these right. So I don't have 3 right, and I don't have 11 right. I got the rest of them right. I missed one.
What do we get on top? 80 minus 50 is what? Okay,
First,
so 30.
I found the speed
Over.
for each
We're gonna
one,
be
so
subtracting
it's
off.
3,000 divided by 35. Then I would
60
do
minus
1,000.
20. You can rewrite it.
And then 25 minutes, 95,000 divided by 5. Then I compared those two. Then I subtracted 80, 57,
30 over.
which gave me 22.5.
You got the answer? All right, what'd you get? Yep. Yep. And because it said deceleration, you didn't have what kind of number. Yes. You always got to do the bottom. So it's all this. Yep. Distance over time. Total distance. Divided by the total time. 100 divided by 80. Yeah, that's what I just told Sarah. What's the total distance? Total time. So you got 100 divided by 80.
So you do 55 on this. Or deceleration.
You understand what David was telling you? Okay.
Alright.
Now, if you haven't gotten down to number 10, 11, and 12, jump down somewhere to 10, 11, and 12. Okay? Because I need you to do at least 1 or 2 on 10, 11, and 12. Okay? Because those are our acceleration questions. Now, if you have finished all 12, the answers are on my desk if you want to check. But you need to show me your paper is finished before I see you at my desk. So Roy, since you're waving yours in the air, I suspect you're done. Let me see it, and then you can check your answers.
You got 23, right?
Yes, you need to check your paper right there by the light. You done? Still working? You check? Where are we at? Okay. So come down and do number 10. Okay.
Oh, where's it?
So nobody turned it. It should be in the notebook closest to me, the one that looks really fast. Okay, you can check. Do not drop all my stuff out of that notebook. You could have just walked around to the other side. Clearly, he does not want to walk around to the other side. Alright, so this one's asking you for what? What is the shuttle acceleration? Virginia, touch the board for a second, and then go back to where the formulas are. I'll come back in a second, it's just slow. It's gotta wake up.
On there?
Nope, now do it. Use the blue arrows. There we go. Alright, see the acceleration formula up there? You gotta use the acceleration formula. Okay, clear your pants up. Alright, you check your answers. A equals BF minus BI over T. I didn't say pull your hoodie down, I said pull your shorts up.
I do, but I keep falling down. I can't, because if they spin me around the way, they're gonna spin me around.
Okay, so the 2 seconds, you do what? Okay, so from on the bottom and subtract. Yep, because time is on the bottom. Now the 2 velocities go away. You subtract it, there's 2 of them. Yep. I don't know. I got enough papers to grade. I spent all night dealing with my son last night. I'm behind as it is, I don't want extras.
Oh.
Bad enough when you're just squeezing it in your hands, we're not throwing it around the room. Then squeeze it. I don't mind just squeezing it. I haven't said a word about squeezing it. When Jacob was ripping it in half, I didn't mind. Is there across the room or up in the air that I have an issue with? Has everybody tried at least one of 10, 11, or 12? So number 10, which formula are we using, Sierra? Okay, so what are you going to, how many times do you have a number 10? How many times do you have a number 10? Question 10, how many times are there? What are you going to do with those 2 times? Yep. So put them on the bottom so you can subtract. Yep. Those numbers are going to be different. Do number 12. You can check the answers. 2 12 is good. Huh. All right, so you got the 2 times down the bottom. Okay, so how many velocities do you have? 2 times 2 is 4. 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 2 times So what are we gonna do with those? Same answer. Formula.
So you're going to subtract it?
Yes, exactly.
They do mentally give me,
Say what?
So you're going to subtract 9 and you're going to subtract it?
You're gonna subtract velocities and the time.
Yeah.
And the velocities are gonna go on top, the times are gonna go on bottom. Yes, except for one small thing. It says deceleration. So if you were listening to Damien a second ago, he said if you subtracted these in the wrong order, what do you have to put on your answer? Yes, exactly. Very good. That one you have to do 3 different things. You gotta calculate Monday speed, Tuesday speed, and then you gotta find out how much you want. You can do it. We did it yesterday in the open. I'm just getting ready to move on. Get an answer yet, Sarah? Now this one, because that one said accelerate. You 3 sit down. What did you do? Subtract the big number or the little number minus the big number? Okay, just split.
So you say it's 3.
Yeah, because it's telling you in this question that she ran 2,000 meters in 45 seconds.
What are you doing?
Monday.
Stop looking at me.
And then she did it on Tuesday, 25 minutes. So you have to find her speed on Monday. And then you have to find her speed on Tuesday. And then you have to subtract her 2 speeds to see how much you ran.
Look, I got interview.
So you have to say speed equals, this is over time. So what's the distance she ran? How fast did she run it on Monday? Okay, that was Monday. For Tuesday, how much did she run? How much did she run? How far? Yep. And how long did it take her to run it? So you have to calculate both of these and get an answer for both of them, then subtract to see how much she increased. All right. For those of you who did not check your answers, okay, because I know there's several of you who did not check. All right, number 1, you should have had 54 meters per second. I rounded off. All right, number 2, 9.1 hours. Number 3, 0.75 meters per second. Number 4, 1.25 meters per second. Number 5 would be an average speed or change in graph because the numbers were not the same in 3 and 4. Number 6, 83.3 miles per hour west. Number 7, 13.4 hours. Number 8, a headwind means it's going in the opposite direction. You subtract 330 miles per hour south. Number 9, I gave you no units, so you cannot write a unit on the answer. 16.6. Now you can make up a unit, miles per hour per second, meters per second per second. You can make something up, but I didn't give you one. Number 10, 28 meters per second per second. 11, 23 meters per minute. And 12, negative 1.5 miles per hour per second. Now, we only have 10 minutes left, so we don't have time for me to hand out gum for y'all to waste. So instead of starting the lab, we're going to finish with momentum, which is our last new formula for the test. And then tomorrow we'll practice a little more math and we'll do the lab the vast majority of the period. The chewing the gum doesn't take that long. The problem is the calculations for most of you. Okay? Momentum is an easy one. It's the easiest formula we're going to do. Find it on your orange card. Okay? Find your orange cards. You don't have an orange card yet? Oh. Yes, you do. It's in your bag.
But I gotta go all the way through that and find it.
Then you can just sit there, but I'm not giving you a new one. All right. Find momentum on your orange cards. Okay.
I'm scared.
Can you find it?
No.
A lot of people have a hard time finding momentum on the orange card, which is why I'm telling you to find it. Okay. What's this at?
P equals W over
Trying.
Okay. P equals W over triangle T is power equals work over time. That's not momentum. That's why I'm asking you this.
Where is it?
Oh, I found it. P equals MV.
equals MV.
Yes. All right. P equals MV.
Where's it all from?
This is why I'm asking this question. Okay? Momentum is P equals M times V. Now, if you look at the orange card, all right, a lot of you guys have noticed that the orange card has all the meanings of what the letters are over here, right? And then it has all the formulas over here. And so you looked over here and you saw, oh, P is momentum. No problem. But you notice there's another P, don't you?
Yeah.
It says power. And then you looked over here and you found a formula that had capital P. And it was power equals W over delta T. That's power. We're going to get to power in a couple weeks. All right? But you need the other P. You need the one that is above it that says P equals MV. Okay? Are we rushing you, Caleb?
No, let's put my hand.
Well, wait till the end of class when I tell everybody that. P equals MV. Now, why are we using the letter P for momentum? Does momentum have any letters P in it? No. M, we use the letter M for what? Mass. N is moles, so we have that already assigned in chemistry. So we don't use N for momentum. T, we all know is what? Time. So there are no other letters in it except E, and we don't use vowels. So the only thing we're left with is to go to the alphabet and find something close to M or N. And so they just arbitrarily picked P, I guess. So when we talk about momentum, momentum is just simply mass times the velocity of an object. Now, looking around, I'm thinking Logan's my only football player here. Nope, Davey. Davey is my football player and Logan. All right, so when we think about our football team on Wednesday night, since they're trying to beat the Storm, all right, a lot of times when you think about your defensive line or even your offensive line, all right, do you want little people or big people on those lines?
Big people.
Why do you want big people on those lines?
Because they can block.
Because they can block, okay? You want to be able to stop other people. So, what things affect the momentum of those people? What affects how effective offensive and defensive linemen are going to be? Their size. So what makes up their size? Their what? Mass. Okay. Their mass. So, on the football team, what does Coach Henderson want those people to do during the summer and during the spring?
Weightlift.
They want them to weightlift. They need them to be strong. They want them to be massive so that they have some muscle, so that they have good momentum off the starting line. Now, the other thing is they want them to have a little what? A little speed. Okay? They need to have a little velocity. Now, if you think about your driver's ed, okay, you probably talked about this with Mormon. And thank you for being taught driver's ed. All right, Coach Mormon probably talked to you about different things that could happen in auto accidents. For example, if you pull out in front of things, what things are going to cause the most damage to you? Okay? If you think about it. Okay? I'm going to draw an ugly picture again.
A train. Oh,
A lot. Okay? Most vehicles are generally 6,000 pounds. Okay? Can't draw a tractor trailer very well, so you have to deal with my god awful drawing. If a tractor trailer is at gross weight,
You forgot that they will.
it's at 80,000 pounds. Okay? Now, that's if it's at gross weight, max gross. A lot of truck drivers, including my husband, have overweight permits. So it's at normally up to 90,000 pounds. So, if you're traveling at a highway speed, which of those is going to have a greater momentum and cause more damage to you in the accident? The tractor trailer. Now, a lot of times people are sort of careless when they pull out in front of other vehicles. It's not that tractor trailers are hateful people and they try to hit you.
They can't stop.
They can't stop.
It takes longer for them.
Okay? This, all of you who've been driving, know when you hit the brakes how long it takes you to stop. At 6,000 pounds. Okay? 3-4 seconds. And you can usually get your car stopped. 80,000 pounds.
It takes like 10.
Okay? That's why you hear about tractor trailer accidents where they jackknife. When they hit the brakes, trying to avoid something in the road, maybe you and your car, they hit the brakes, the trailer hits the brakes, the trailer swings sideways. That's what jackknifing means. The truck goes straight, the trailer goes sideways where they try to avoid an accident. Okay? They cannot stop on a dime. That is mass and velocity that has a tremendous momentum that's all coming forward towards you. Now, somebody mentioned a train. Think about a train. Okay? They can't stop either. They can lock it down. Those are metal wheels on metal tracks. Okay? They're going to slide. They're not stopping. Okay? Mile down the road, they might get stopped. But they're not stopping for what's on that railroad track. So when you see those lines and you go to Winston and you see those people who pull up, like on Haynes Mall to go across Stratford to go down by Costco and Chick-fil-A and all those people, they sit on those railroad tracks? Don't do that. I don't. I sit behind the white line. Okay? I drive a brand new 2018 Explorer. I have enough sense to know that if somebody comes in a train, my car's getting wiped out. If I'm sitting in the train, I'm getting wiped out. I prefer not to. Now, we will practice the calculation tomorrow, which is very easy. And we will do the chewing gum lab tomorrow. Okay? We should have time to do the lab, to review for the test. If we're here Thursday, which we should be, practice forces and learn a little bit about it on Thursday. If we're not here Friday, that means the test is Monday. If you have a calculator, put it in the tub. It would be whenever we come back. Hopefully, we'll just have a little wind and rain and no damage if we're not here.
Once the school gets
It's not going to get lifted off.
When is the tree fall?
No, that is possible.
Once the roof comes off, though.
Could we be a little more positive?
No. I'm one of those people that think they got a memory.
All right, y'all have calculators. Get them up here. Who sits behind tonight? Whoever the kind soul is who hands out calculators needs to be a kind soul and get him back up here too. Thank you. Thank you. I'll be here today and tomorrow. Tomorrow I'm only going to be here about 4:15, unless I can convince my husband to deal with my son. Right now, I can't go to Charleston because of the hurricane. So if he can deal with the haircut, then I'll be here longer. Okay, but right now I'll only be here 4:15. Yes, ma'am. Yes.
Oh, can I go to the
Yes, you can. You know how to get to the guy's office? Okay. You're welcome.
You know I gotta go to Mac 3 stuff. I'll go. Mac 3 stuff.
I'm sorry. I only read half of it. I got down through the list of crap, and then I didn't get much further. Me too.
I honestly think they'd make it up.